let's take a look at a couple of applications of quadratic functions. And I think on this video we'll do two of them. One will be where you are looking at something like maximizing profit, or in this particular case, determining marginal cost, which or a minimum or maximum value related to marginal cost. When those kinds of questions come up with quadratic functions, or you're looking for a minimum or maximum, you really are just looking for the vertex. You're just not graphing it. You're solving the application by vertex solution. So let's just read the problem and then we'll go ahead and work it out. So it says here, the marginal cost of a product can be thought of, and by the way, this problem is similar to problem 91 in 4.3. The marginal cost of a product can be thought of as the cost of producing one additional unit of output. For example, if the marginal cost of producing the 50th product is $6.20, it costs $6.20 to increase production from 49 to 50 units of output. Suppose the marginal cost, C, in dollars, to produce X thousand MP3 players is given by this function. Well, what they're saying is that with marginal cost, your costs may vary depending on how many units. For example, you may have to hire more employees or add a piece of equipment or run an extra shift. And so that would go ahead and change your cost per unit when you go ahead and go from a certain level of production to another. So in this particular case, the first question says, how many players should be produced to minimize the marginal cost? So we want the level of production that would cause the cost per unit to be minimum. Now we better be careful here to make sure it is asking us for how many players. We better find out, is that X or is that C of X? And in this particular case, it did define up here, it said that X was the number of thousand of MP3 players. So it does seem like if they're asking how many players, we're looking for the X coordinate of the vertex, not the output value, the Y coordinate of the vertex. So this will be easy. We're just going to go ahead and find negative B over 2A. In our case, B is negative 140, so negative B would be 140 positive over 2 times 1. And it turns out that answer is 70, or 70,000 MP3 players would be the level of production that would cause me to go ahead and have the cheapest per unit production that I could have. Okay, so let's go ahead and take a look here at part B. It says, what would be that minimum marginal cost? In other words, at 70,000 units, we're going to go ahead and be producing MP3 players at a cheapest per unit cost. So let's go ahead and see what that cost would be. We're going to have to plug 70 into the formula and get that to work out. And so we got here C of 70. And that is going to be 70 squared minus 140 times 70 plus 8,100. And if we put that in our calculator, I think we would get an answer of $3,200. Okay, so that would equal $3,200. Now, this problem really is not realistic as far as I doubt it's going to be costing them $3,200 per unit to make an MP3 player. That is kind of ridiculous. But it turns out that it just wasn't a good practical model. But if we had something more practical, we'd just be working it out the same way. Okay, so to fill in the answers here, this would be 70,000, and this right here would be $3,200 per unit. So when you go ahead and you do your problem for homework, if you see you get an unusual answer, it might be for similar reasons that they just didn't pay close attention to the results on this particular model's answer, and take a look at how practical that would be.